Welcome back to our week 11 class that we are going to talk about more on code and standard in this class. In our very first class, we have talked about the OSHA standards and terms, and then we also have talked about the process safety management, and also we talk about the Environmental Protections Agency. And in this class, we are going to talk more about the international standard like British standard, ANSIs, and also a few more. First of all, I would like to introduce you to the OSHA Malaysia website. You can actually go to www.dosh.gov.my and to look at what are the informations that regarding to Malaysia Department of Occupational Safety and Health has in this portal. So if let's say in the events that you need to apply for permissions, like if you work with high pressure vessel, for example, there are a few forms that you need to fill up and apply for permissions in order for you to commission or to run those equipments. You can all get all of those informations from this website. As mentioned before, one of the methods to monitor and control the accidents and loss statistics is the OSHA incidence rate. Remember, we talked about it in chapter 1 that there is a lost workday and also the incidence rate. So these are the standard terms, just as a revisions that used by OSHA. For example, what is first aid? What do they mean by incidence rate? What do they mean by lost work days? And also medical treatment, occupational injuries and illnesses. Okay, injuries and illnesses are two different things. Injury is like simple things like paper cut or to like major accidents or falls or anything that cause a physical injuries. Occupational illnesses is where it defines to a disorder or abnormal conditions that cause due to your occupational injuries or due to extra exposure to the environmental toxicants. So this includes acute or chronic illnesses or disease that may cause by inhalation, absorptions, digestions, or direct contact. Another important terms that used by OSHA is all the recordable cases or the recordable fatality cases or even like non-fatality cases without lost workday. So every case or every incident in the workplace must be recorded and reported. So these are just a recap on this non-fatality case without lost workday or lost workday cases due to restricted duty, etc. And this slide shows about the accident statistics for selected industry in agriculture, chemical products, mining, constructions, manufacturing, etc. That talks about those recordable cases or those lost workday and also fatality rates per 100,000 employed. And also it compares to the FAR records recorded in the UK. Another important agencies that are related to occupational health and safety is the EPA, the Environmental Protections Agency. This is the websites in US. The reasons I'm showing you this website is that they basically list out almost all the chemicals and toxics that exist that they have tested, and the data are all in this website. So this website is actually comes very handful or resourceful when you want to check on the toxicities of certain chemicals that you're working with where you couldn't find the data elsewhere. Look at this website. In Malaysia, we have a similar counterpart, which is our Departments of Environmental DOE. So in our local DOE website, this is where you always find that where you can get your scheduled waste agents. You can also look at it for our the air pollution index. Every time when we have haze, that's where the websites you will refer to look at is our air is at the healthy level or not. So this is the websites that I'm talking about, the Departments of Environment Malaysia. So refer to this website if anything you want to look at the local applications. One of the important things that I want to bring to your attentions today is about the Schedule Waste Guideline. A lot of people thought that, oh, chemicals, what do we do with the waste, chemical waste? There are certain classifications or there are certain rules and regulations regarding all these chemical waste. We can't just pour anything into the drain and let it flow to the indoor water, because that will actually contaminate and kill the bacteria in indoor water. And indoor water can only treat our biological waste, human biological waste in their plants. So everything else is actually under this Schedule Waste Guideline. So what are schedule waste? Schedule waste are generally groups of waste generated by the industrial or service sectors, which are categorized under the local environmental law. And so we have this act called the Malaysian Environmental Quality Schedule Waste Regulations 2005. In this act itself, it lists those schedule waste in 5 different categories. First thing is that not all categories are toxic chemicals and not all are industrial waste. So we can look at them one by one. So the top schedule waste, this stand for short form for SW. One is on metal and metal bearing waste. So if you have any metal related chemicals, then you have to label them as SW1. SW2 are all the other inorganic materials. It may contain mixture of both metals and organics. So for SW1 is purely metal, SW2 is mixture of both. Okay, and SW3 is more on organics, but it may contain some trace of metal and inorganics. Okay, and SW4 has to be either organics or inorganics. It's very clear cut. Okay, and SW5s are all residues of other waste, especially for students who are going to do your FYP next year. Any chemicals that you have mixed in the lab, please do not just pour them away into the drain. Yeah, ask from our lab assistants or lab technical officers for the schedule waste bottle, and you have to label what waste are they. For example, wastewater, or ethanol, alcohol waste, or if there is a mixture of alcohol with organic solvent, for example, list them nicely so that when every Tuesday and Thursday we actually have contractor coming into the campus to collect all these schedule waste for treatment before they release back into the river. So the labeling itself is very important so that they will know what to trace, what to treat. Like if it's an acid-based chemical, then they have to neutralize it. Or if it's some base chemicals, then they have to neutralize them. If it's a metal-based chemical, so then they will have to extract the metal out from the system by those, acid-based neutralizations, so that before they can proceed with the other treatments. So this is very important. So do not just pour waste into the drain. Previously, we have students accidentally or doesn't know anything about the schedule waste. They just pour whatever chemicals into the drain and causes an evacuations of the lab. So please make sure that you know what to do next. Yeah. And of course, there are ways that we want to, talk about. There are ways that we want to recycle. There are ways that we want to manage. We call the waste management. So waste management normally come from like what we call a few R's. Either we reuse them, we recycle them, we recover them, or the worst case that we can't do anything, then we have to dispose them in a safe manner. So risk management plan, or RMP, is actually a plan or a management system to help us to reduce the number or magnitude of accidents if everything is understood and practiced as intended. And also it helps us to protect off-site peoples and environments. Risk management plan focus more on environment actually. And so we also look at if there's hazardous chemicals, then it is our responsibility to neutralize or to look at the consequences and probability of this risk if there is any potential outbreak. A few important elements in our risk management plan is first the hazardous management assessment, and then we talk about how do we prevent them, the prevention programs. And when there's no way that we can prevent it or there's accidents already happen, then what is our emergency response? And also all the documentations that is maintained on the site that up to date if any changes occur. So the hazardous assessment, of course, covered all the consequences analysis for a range of potential hazardous chemical release. And also we look at things like worst case scenario from the history, like what we call a case study, which I believe you are doing it right now, your as our assignment 1, your case studies. And also we look at the risk matrix to characterize the worst case scenario and a more likely scenario. So in this risk assessment matrix, we talk about 3 things. First is the consequences, like considering the consequences of a potential risk or scenario must be considered, or even the worst case scenario. And the likelihood is like the occurrence, how often the things happens. So the risk assessor judgment must be based on the prevalence of the problem or hazards and the outcome, backed up by experience and data. With all these past incidents, complaints or claim. That is where near-miss accidents are very important to be recorded, because a lot of people would think that, hey, it's near-miss, it doesn't happen, the accident didn't happen, so why do I want to record it? Near-miss accidents is one of the important data to tell us, look, there is a potential risk or accidents to waiting to be happens. It happens, but nothing happened. Means we call it a near miss. So that tells us there is a chances that this might explode, might happens. Yeah. So near miss accidents data is one of the most important, or one of the important documentations to be recorded in the likelihood here. Then we evaluate the outcome, the consequences versus likelihood, to let us know what is the significance of the risk, like low risk, moderate risk, high risk, or extremely high risk. So these are some what we call the toxic endpoint specified by the EPA. Yeah, you can take a look at this, or you can find more data in the EPA website. So what I want to bring to your attention is this, what we call the risk assessment matrix. So you can see there is a likelihood versus the consequences impact. And if, let's say, things that is likelihood to happens, most certain that it will definitely happens, we give a level 5. Things that only happens that 1 in 1,000 years, we give it at the level 1. And then we look at the significance of the consequences. So if, let's say, it doesn't matter, when it happens, it's just maybe just a hiccup, or maybe even nothing will happen. That when things fail and nothing will happen is so insignificant, then we give it a 1. But if it's extremely impactful, okay, the consequences, as long as it involves injuries or life, we will definitely give it a level 5. So how do we look at how bad the scenario is that consequences 5 is definitely something that we want to look at, and also likelihood 4 and 5. Okay, so anything that is between 4 and 5 over here is where we want to look at. So we take an example. If something so definitely happens, almost certain that this will happen, and the consequences is level 5. A total level is 5 times 5 give you 25. Means this is a very high or extremely high risk piece of equipment that we must look at it. Okay, so if let's say the likelihood is definitely it will happen, and the impact is major, level 4. So we times 4 times 5, we get a 20. Same with here. So cases like this, anything that is beyond 17, we classify them as extremely high level that we want to look at. So the red zone here that you can see is something we will definitely take actions first to prevent it, to reduce it, and even to come up with, if this happen, what is our emergency responses. Okay, so that's the red zone. And once we are done with the red zone, the next thing is we are going to look at all the yellow zone one by one here. Oops, I should have used another color. Anything that is under the yellow zone, we will then look at it. Anything that is between 10 to 16. Okay, we first settle the red zone, then we look at yellow zone. Anything that is at the blue zone here, okay, the green zone here, is something that we can put it aside. We don't have to take any actions, or we can just do nothing. No point wasting your efforts or money in here. Yeah. So that explains the risk matrix, how we look at it and how we take actions according to that. In the next few slides, I'm going to introduce you to certain standards that is being widely used internationally. First standards we look at is the ASTM standard, or what we call the American Society for Testing and Material. So if you are doing any research, like FYP, or even if you plan to continue with your master or PhD, or when you go to industry, and for example, if you want to work in a polymer industry, you want to know what is the what is the standard of strength. What do we mean by a good polymer versus a weak polymer? The way to test them are all being structural and nicely prepared in this ASTM standard. Yeah, so they are actually written by group of people, those experts that they have tested it, and they have meetings about how do we standardize the testing materials. Okay, so this standard is mainly for tests and talk about material itself. Yeah, talk about how do we enhance the product quality, enhance safety, etc. Okay, so if you want to tell people, oh, my product is of good quality, and you can tell them because we test against ASTM 9001 standard, for example, or 8005 standards. It helps us to build, it helps the company to build consumer confidence. Okay, so if you want to look at all the standard, you can go to astm.org website. And just a brief overview of what ASTMs are. So it actually is contributed by, we call a group of volunteers. And these people, they are the experts, they are the professionals, they're representing 150 countries that we work together to look at all these different testing. Okay, and then we put all the test method together, the specifications, and we have meeting, and then we see how we can support industry to ease their standard. And that's where ASTM standard has been developed. Okay, a bit of a brief overview of where ASTM standard come from. It started in 1898 by a group of chemists and engineers. Okay, and you can read about their background through their website as well. This is what I get directly from their website. So where do we use ASTM standard? Okay, ASTM standards are used by individuals, companies, agencies, and all these standards we have to purchase them. It's not free it's not like open source, you can just take it. So because it is a work done by all these professionals, even though under volunteers scheme, but the monies that you use to purchase these standards go to maintain those publications or editorials or all these expenses. So certain governments actually use ASTM standards to say this is the standards. If you don't pass this one, we will not allow the company to sell certain products. So it depends on which companies or which governments or what other governments standards talk about. In Malaysia, like for example, the Malaysia Plastic Manufacturing Association, MPMA, their standard they use is not ASTM standard, but we use ISO standard. Yeah, which I'm going to talk about it next. UL standard is another standards, but talks more about chemical safety. Talks about renewable energies, talk about sustainability, and in nanotechnology. Okay, ANSIS is another standard. It's American National Standard Institutions that talk about ISOs and etc. So this is also another standards that you often come across when your supervisors or in your FYP will ask you, okay, if you want to test certain thing like for example, tensile, there are standard in ASTM standards. So make sure you use those correct standards. Okay. ISO is another standard, so make sure you also refer to the correct standards when you want to do certain things. Like for example, ISO 9000 talks about management standards, like how an organized manage things. ISO 14000 talk about environmental standards. ISO 18000 talks about safety standards. So there are different categories with different codes, talks about all these different standards. You can look at the official websites about all these organizations, and also you can refer to our safety textbook. And with this, I believe we are done with our class today, a very short class. Just a simple introductions of what standards are. Thank you and have a nice day. So this week there's no tutorial classes. Please focus on your presentations and also complete all the assignment too if you still have a few to go, because you need the minimum 8 CPD hours to fulfill that. And next Monday onwards, I will release the final assessment in times so that you can start working on your final piece of work for this module. Thank you and have a nice day.